Now, electron affinity is getting probably a little bit too advanced. It'd be nice to leave this until the high levels can actually do the Born-Haber energy cycles, so that they can actually, this is how they actually determine it. It's like using Hess's law and mathematically combining a whole heap of different reactions to get this reaction. So the whole concept is a little bit more trickier. It's the energy released when 1 mole of electrons is attached to 1 mole of neutral atoms or molecules in the gaseous phase. You need to be able to write that out. And so what we do is this one here, there is an increase in entropy on this side, and on this side enthalpy is favoured. So energy is released when this bond, when this joining occurs. And to break that apart in the opposite direction, energy needs to go in. So this is the endothermic side, and this is the exothermic side. So energy is released here and energy goes in on this side. And this side is more favorable to entropy, and this one is more favorable for enthalpy, the release of energy. And so when you have that situation there, a favorable enthalpy, the delta H is negative. And so as you can see, you've got these negative kilojoules per mole values. So jumping across quite a lot here, that's sort of kinetics and equilibrium and so forth, to get to that value. Okay, so the trends are what you would see. So the better negative value here means it's much better at gaining that electron, mole of electrons in the gaseous phase. And you'll see that the trend, the periodic trend here, we'll just do that one first. So they're all in the same valence electron shell, but there's an increasing nuclear charge, so they have a better and better ability to gain that electron. So you can see generally there are little ups and downs. That is increasing as you go across a period. It has a much better ability to gain the electron. And as you go down, as you hopefully would expect from quite a lot of trends, you can see the valence shell or the principal energy levels getting larger. And so the distance of the outside electrons to the central nucleus is much greater, which has a huge effect on its ability to gain an electron. So you can see as you go down, these values get smaller and smaller. So they're becoming less and less negative, and they're becoming positive. So minus 60 going, dropping little bits and pieces. All right, so minus 53, minus 48, minus 46, rather than these huge values, which is a minus 300, which is far more energy being released.